Hello future actuaries, my name is Emmanuel Dani. My goal with this channel is simple: make any actuarial exam questions easy for you to understand and get you ready to pass your exam. And today's exercise is going to be focused on the topic of interest measurement. Before we get right into it, don't forget to subscribe and hit the like button. Let's dive in. So our question today is this way. Bruce deposits 100 into a bank account. His account is credited interest at an annual nominal rate of interest of 4% convertible semi-annually. At the same time, Peters deposits 100 into a separate account. Peters' account is credited interest at an annual force of interest of delta. After 7 years, 0.25, the value of each account is the same. Calculate delta. So, I'm going to take you through steps that I believe will help each one in his preparation to approach any question in exam P and exam FM especially. So, those are the steps down here. Yeah. So we will go through step 1, step 2, step 3, step 4 to be very clear about what is the question about and to solve it easily. So let's go. Step 1. Step 1 is to break down each sentence into mathematical concepts. So what do I mean by breaking down into mathematical concept? We are going to graph to know the account of Bruce and his deposit. So Bruce deposited 100 at time 0 at an interest rate of 2% semi-annually. And Peter does the same thing at the same time of 100, deposited 100 in his account at an interest, a force of interest, which is delta. So we then move to the second step, which is to write down the numerical data with their corresponding mathematical symbols. Here we go. The account value of Bruce at any time is written this way: 100 times 1 plus I upper 2 over 2 exponential to the power 2 times t. Same with Peter's account. 100 times exponential delta times t. The last equation is that at the same, Peter's account is credited, but after 7.25 years, the value of each account is the same. So that is what we are going to write mathematically. Yeah, at time t equal to 7.25. we have this. So the accounts are the same. Okay, the account value are the same at that particular moment. So we move on to step 3. Now, step 3 tells us that we make some transformations if needed. But in this case, it's a very simple exercise. So we don't need to make any transformation or converting any value here. So we move on to step 4, and step 4 is to write the goal. What is the goal? And our goal here is delta. The reason why we need to write a goal, the goal is to not mess up around when we are solving the question. We have to have all these points very clear in our mind so that we will solve our question very quickly. Now, let's dive in solving the question now. So remember, at time t, 7.25, both accounts equate. So we write that equation in order to find our delta. So we will have 100 times 1 plus 2%, exponential 14.5, and 100 times exponential 7.25 times delta. So we cancel both 100 because they equate, and we take the logarithm Neperian on each side, and we'll have this equation. Now, why do we write this 7.25 times delta? How do you get to that? Remember, when we take the logarithm Neperian of exponential, ln of EA equal to A. Okay, so we move on to find delta, which is equal to 0.0396, which is our final answer, which is C. Thank you for watching this video. I thank you guys, and I will appreciate any comment, especially if you have different ways to solve this particular question. Don't hesitate to share. Also, don't forget to subscribe to be the first to receive my latest videos. Good luck with your exam.